We're given f of x equals 2x to the fourth minus 5 e to the power of x. We want to find the first derivative function, f prime of x, then f prime of negative 1, then the second derivative function, or f double prime of x, and then f double prime of negative 1. So we'll begin by finding f prime of x, which is equal to 2 times the derivative of x to the fourth minus 5 times the derivative of e to the x. Well, the derivative of 2x to the fourth, we'd multiply by 4, that would be 8. Subtract 1 from the exponent, we'd have 8x to the third, minus 5 times the derivative of e to the x. Well, the derivative of e to the x is e to the x, so we just have minus 5 e to the power of x. And now to find f prime of negative 1, we substitute negative 1 for x. So we'd have 8 times negative 1 to the third minus 5 e to the power of negative 1. Well, negative 1 to the third is negative 1. 8 times negative 1 is negative 8. And then for 5 e to the negative 1, we can make this exponent positive by moving it to the denominator. So this would be the same as minus 5 divided by e. Let's also get our decimal approximation for this value. We'd have negative 8 minus 5 divided by, on this calculator, if we press second divide, it brings up the e, and then enter. If we round to 3 decimal places, notice how the 3 in the fourth decimal place tells us to round down. This would be approximately negative 9.839. Now we want to find the second derivative function, which would be the derivative of the first derivative function. So we want to find the derivative of 8x cubed minus 5 e to the x. Well, the derivative of 8x cubed would be 24x to the second. And the derivative of e to the x is e to the x, so we just have minus 5 e to the x. And now to find f double prime of negative 1, we substitute negative 1 for x. Which would give us, this would be positive 1 times 24, 24 minus 5 divided by e. Let's get a decimal approximation for this as well. So we have 24 minus 5 divided by e. Again, to 3 decimal places, notice here we have a 6 in the fourth decimal place, so we round up. This would be approximately 22.161. Now let's look at the graph of our function, and at the point on the function when x equals negative 1. The original function is graphed here in blue. Notice when x equals negative 1, this would be the point on the function. To find the corresponding y-coordinate, we'd have to substitute negative 1 into the original function. Notice at this x value, the first derivative is approximately negative 9.839. This tells us the rate of change of the function at this point, and also the slope of the tangent line at this point. So the slope of this red tangent line is exactly negative 8 minus 5 divided by e, which is approximately negative 9.839. And also, because the first derivative is negative at this point, the function is decreasing at this point. Notice the second derivative, or f double prime of negative 1, is approximately 22.161. This tells us the rate of change of the slope of the tangent line at this point, or we can say the rate of change of the instantaneous rate of change of the function at x equals negative 1. And because it's positive, at this point the slope of the tangent line is actually increasing, meaning as x increases, the slope with this tangent line would increase. It also tells us something about the concavity of the function at this point, and because it's positive, the function is concave up at this point. But we'll talk more about increasing, decreasing, concave up, concave down in future lessons. I hope you found this helpful.